Welcome to AP Comp Sci Summarized. In this video, we will tackle the basics of Java as well as some important vocabulary. What is Java? Java is an object-oriented programming language, meaning that coding with Java primarily relies on the manipulation of data storage and objects, which we'll go more in depth into later. Java is what is known as a high-level language, which means that it is comprehensible to the everyday person like you or me. This is contrasted with machine language, which is only comprehensible to machines and people with too much time on their hands. Why use Java? Here are some pros and cons. Pros include that Java is easy for beginners to understand, is in English, and other people's packages can be imported into your code. Some cons are that for some people it can be hard to understand, and that like English, you're never quite done learning it. There's always new syntax or vocabulary you're learning specific to the type of programming you're coding, whether that's to understand poorly written API documentation or just learning the basics. How does a Java program run? In order for you to be able to code, you should be able to understand how code actually gets turned into a program. To run any program in any language, three things are needed: an IDE, a compiler, and a runtime environment. Code is first typed into an IDE or an integrated development environment. Examples include programs like NetBeans, Eclipse, or even something as simple as Notepad. When you decide to run your code, the compiler, for the Java is the JDK, converts your high-level code into an intermediary, universally understood language known as bytecode. From there, the JVM, or Java Virtual Machine, will act as the runtime environment and convert the bytecode into machine code numbers that can actually be executed by the computer. Writing your first program. If you're following along, go ahead and open up your IDE. Let's create a new Java class and name it hello.java. For most IDEs, you should notice that the class template is already made. Note the class name is hello, the same as a file name. This must be true or the file won't run. Java is a case-sensitive language, but not whitespace sensitive, meaning that if you were to type public with an uppercase P, your program won't run, but if you were to never press enter and write all of your code on one line, it will still run fine. That being said, don't do that. Only a monster would do that. On the AP test, you'll be writing your code on paper, so make sure you have the hang of all these capitalization standards. After the class name is a curly bracket, which in Java denotes the information stored within a container, which in this case is the code for hello.java. All open curly brackets must be followed by a closed bracket logically, or the program won't know when the information, like the class for example, ends. Okay, let's get back to our program. If we want something to execute from our class, we need a main method, which is the only method actually run by a class. It is not necessary for all classes to have a main method, especially if they're only used as objects. Type in public static void main string brackets args, just as seen on the screen. For now, you should just memorize that exact line when writing your main method. Public and static denote the size and scope of the method, which is something you don't need to worry about for now. Void refers to the return type of the method, which in this case is void or nothing. Basically, by executing this method, nothing is returned to the computer, which may seem counterintuitive now but will make sense when we look at the methods that do have return types. Main is the name of our method, which is necessary in order for it to get the special properties of a main method. This will make more sense when you see examples of other methods. Alright, editor, quicker education here. So I forgot to mention something when actually making the script for this video. So one thing you actually have to do is make a project first. That can be easily done by going to File, New Project. And this is probably the same in almost any IDE. And basically, you want to get like a normal standard Java application. So here I'm using Java with Ant. Java with Gradle will require me to build the Gradle, which is really not important for the kind of basic stuff we're doing. You can also make one with Maven, but I don't recommend it. Anyways, yeah, so once you've created your application, inside your source packages, there you can put your project. For this project here, I have named it Java Application 1. And if you notice, I have to import the package statement right here at the top of the program, otherwise this won't run, similar to how this name has to match the file name. So yeah, once you do that, you're basically set for this whole project stuff. You'll see why packages get more important in future videos. Inside the main method, type system.out.println hello world, followed by a semicolon. In Java, all statements must be followed by a semicolon so that the computer knows when a command ends, similar to how a period tells you where the end of a sentence is. Run the file and voila, you've run your first program. If you did this correctly, hello world should have been typed into the console. To illustrate what I meant about method names earlier, go ahead and type the following line as you see it on screen. Public static string hello, parentheses, brackets, return hello. If we run the program again, note how nothing is changed. This is because the hello method is not read by the compiler since it's not part of the main method. In order to execute this method, we must reference the method in the main method, which we can do by simply typing system.out.println hello parentheses in the main method. How this works is that the compiler reads the main method, which tells it to go and execute the hello method. The hello method then returns a string to the compiler, which the compiler will then give to the system.out.println method. Note that all these types have to agree or we get an error. If instead of returning a string we returned a number, we would get an error because the method header told the compiler that it was going to return a string. And even if the method header did agree, if the data type was not the one the method can understand, like for example a boolean, we would still get an error. Now is a good time as any to go over data types. There are 8 primitive data types, or ones that aren't objects. The byte, the int, the short, the long, the float, the double, and the boolean, and the char. Bytes, ints, shorts, and longs are all store integer values, but are scaled to have different storage spaces. So if you wanted to store a big number, you could use a short, but if you wanted to store a small number, you could use an int. In the end, it's all about optimizing the space your program takes, because if you're careless with data storage, your program could take up way more disk space than necessary. Doubles and floats hold floating point values, or in normal speak, decimals. Finally, chars can hold a single character like b or ampersand, and booleans can be set to either true or false. Variables, like in math, can hold numbers, and in programming can hold other things as well, as long as they're correctly defined. In order to create a variable, simply write the data type, the name, and then equals a value. Incorrectly stating the data type will result in an error. To rewrite a variable, simply write the name of the variable equals a new value. You do not need to state its type again, as that has already been established. The compiler reads from top to bottom, so whatever is the current most value of the variable stays that value. Operations. There are 5 basic operations that can be done in Java: addition, subtraction, multiplication, division, and modulus. Modulus, if you're wondering, divides 2 numbers and gives you the remainder. So if you wanted to add 2 to x, write x equals x plus 2, or x plus equals 2 for short. This principle applies to all operations. You can also add variables together, for example, z equals x plus y. Java follows basic PEMDAS rules, but there are a few caveats to Java math due to floating point errors. Since ints, shorts, bytes, and longs can only store integer values, attempting to use another operation such as addition with a floating point value like a double will result in a mismatch error, since any time an integer and a double are combined, the end result is a double. Doubles and floats can hold both integer-double combinations as well as integer-integer combinations, except that the latter will automatically be converted into a double when it gets stored. The astute thinker you are, you may be wondering then, what happens when 2 integers are divided that don't go evenly into each other, like 10 and 4? Instead of getting 2.5 like you'd expect, the compiler will return 2, because the computer will always cut off the decimal place at the end. This happens even if the value is stored in a double, as the process of actually converting the value into a double happens after all the math is done, returning 2.0. To get around this, either make one of the numbers a double by adding a 0.0 to the end of it, or cast the integer as a double by writing double in parentheses like this. This tells the compiler to convert the value immediately coming after, in this case 10, as a double. Now the compiler returns the expected 2.5. Casting only works for certain types, so you can't do something like cast an integer as a boolean, but what you can do is cast a double as an int, which will cut off the decimal at the end if that's something you want. And that basically covers the very basics of Java. Like a house, without a strong foundation, you cannot hope to become a good programmer. Thanks for watching. If you have any questions concerning the topic covered in the video, feel free to ask and I will answer them in the comments below. Leave a like and maybe subscribe if you found this video helpful. Thanks for watching.